All right, so just like how finding the derivative of the exponential function e to the x is super easy, so is also finding the integral, because if you take the integral of e to the x dx, that's just going to be equal to e to the x plus, plus your constant c. And using u substitution, if you have the integral of e to the u du, that would just be equal to e to the u plus c. So it's actually really simple to integrate the exponential function as well. So let's go through a couple of examples to see how this works. So the first one we have the integral of e to the 3x plus 1. So here we're going to use u substitution, and we're going to make the u equal to 3x plus 1. And then the du will be 3dx. Now we don't have 3dx in our expression, but we have dx. So we're going to make this 1/3 du equal to dx. And then we can rewrite this integral as the integral of 1/3 e to the u du. This 1/3 looks a little sketchy. Let me clean that, make it a little neater. 1/3 e to the u du. Okay, so now from here, it's super easy to integrate, because this will just be equal to 1/3 e to the u plus your constant c. And all you gotta do is resubstitute the 3x plus 1 in for u to get our answer. 1/3 e to the 3x plus 1 plus c. And there you go. Now, I recommend especially when you first start with these types of problems, to check your answer, because it's really easy to check your answer, and it makes sure that you're gonna get the answer correct. So in other words, if we took the derivative of this, what we would do is take the derivative of 3x plus 1, which is going to be 3, and multiply that by this entire expression. So 3 times 1/3 e to the 3x plus 1. The derivative of the constant is just 0, so it goes away. And you're going to notice you're just left with e to the 3x plus 1, which is what our original integrand is. So we know we got this correct. So really take the extra time to check your answers, especially when you first start practicing these types of problems. All right, let's look at B. Right, B, we have 5x e to the negative x squared. So here we're going to make the u equal to negative x squared. Then du will be equal to negative 2x dx. Now we don't quite have negative 2x dx, but we have 5x dx. So what I have to do is just simply multiply this by negative 5/2, because we multiply both of these sides of the equation by negative 5/2, you can see what happens. The negative 5/2 du equal to negative 5/2 multiplied by negative 2x dx. And then these negative 2's will cancel, and all you're going to have is 5x dx left. So you have negative 5/2 du equal to 5x dx, which is what we have left over. Now, like, you're probably wondering, how do I figure this out? How do I know to do that? You just got to practice with this stuff and think. I've been doing this for hundreds of years, so this stuff is going to be super, quick for me to figure out. But again, it's just that I've done a lot of practice, so don't worry about it. Just keep on practicing, and you'll eventually catch on to these tricks and patterns. Anyway, so continuing on, we can rewrite this now as the integral of negative 5/2 e to the u du. And now we just have to integrate this. Remember, the negative 5/2 is just a coefficient, so that can always be factored out. And all we're taking is the antiderivative of e to the u, which is e to the u plus our constant c. And we just resubstitute negative x squared in for u. And we'll get negative 5/2 e to the negative x squared plus c. And again, you can check your answer by taking the derivative of this, and you're going to find that you're going to end up with this integrand here. All right, two more. All right, here we got e to the 1x over x squared that we're taking the integral of. So what we're going to do here is we're going to make the u 1 over x. Now again, how do I know to make u 1 over x and not x squared? Again, I've been doing this a long time, but in either case, if you try, you can always try x squared first, and if you see it's not working out, then try the other thing. Again, it's just trial and error a lot of the times when you're doing u substitution. Anyways, this is the same as x to the negative 1, and then so when you take and find du, this will be equal to negative x to the negative 2, which is the same as negative 1 over x squared, which is pretty much what we almost have here. Because remember, this is just like 1 over x squared times e to the 1 over x dx. So don't let that confuse you. But now we just make this negative. So we're going to have negative du equal to 1 over x squared dx. Whoops, I forgot the dx actually. Yeah, 1 over x squared dx. And then from here, I can rewrite my integral as the negative of e to the u du. It actually just becomes that simple. And then this just becomes the integrated negative e to the u plus your constant c. And we're just going to replace now u with 1 over x. And we'll get negative e to the 1 over x plus c as our final answer. All right, for d, we got the sine of x times e to the cosine of x. So we're going to make u the cosine of x. And that's because we have the derivative of the cosine of x, sine of x dx left over. Or not sine of x, but the negative sine of x technically. Negative sine of x dx. And then all we have to do is make this, pause this, we have negative du will be equal to the sine of x dx. And then we can rewrite our integral as the negative e to the u du. And then we integrate this. This just becomes negative e to the u plus c. It's kind of funny. And then we replace u with the cosine of x. And our final answer will be negative e to the cosine of x plus our constant c. And again, you can always check your final answer by differentiating and make sure you get that original integrand. All right, so there you go. Good luck.